Last time we talked about multiplying fractions. That was the last thing we talked about. Today we're going to talk a little bit more about fractions, then we'll be at the board for a long stretch. So have you guys ever heard that term reciprocal? I mentioned that a second ago. So any number times its reciprocal is blank. Do you know what the answer is? It's 1. Yeah, any number times its reciprocal is 1. The one exception to that is which number? 0. Except 0 because 0 does not have a reciprocal. Okay, so any number times its reciprocal is 1. One exception being 0. So let's talk about finding reciprocals really quick. Do you guys know what the reciprocal of negative 2/3 would have to be? Go ahead, Anna. Negative 3 over 2. That's right. So all we're doing with the reciprocal is simply flipping the numerator with the denominator, and we do leave the sign the same. So if it was negative, the reciprocal is negative also. Positive stays positive. All right, what do you think about the reciprocal of 8? Go ahead, Ashlyn. It would be 1 over 8. Correct. Makes sense to everybody? Because originally it was 8 over 1, so if we flip the numerator and denominator, we end up with 1 over 8 for a reciprocal. Okay. Good? Awesome. All right, let's move ahead to our final couple of examples here. Dividing fractions and then adding and subtracting fractions are right here. So the first one here, number 3, says divide and reduce to lowest terms. And so I've got 2/7 divided by 4/5. So when you are dividing fractions, we talked about this the other day when we were doing our Kahoot. What's that little phrase maybe that you learned in middle school? Go ahead, Hosanna. Copy dot flip, or sometimes people say copy dot flop, but same thing, of course. So copy just means to take the first fraction and totally leave it the same. Don't do anything to it. So I will do that. 2/7. And then in both of those phrases, dot is in there, right? So what does dot mean?
Multiply.
Take the division and make it multiply. That's right. So times, and then flip or flop, however you want to say it. 4/5 is going to be flipped or flopped into 5/4. It's just the reciprocal of that second fraction. So it's always in that order. It's always copy, dot, flip. It's never the other way around. So then, maybe you remember from yesterday, when you're multiplying fractions, you take the numerators and you multiply them together. You take the denominators and you multiply them together. And so in this case, we would get 10 over 28. And that does reduce. Do you guys know what factor it reduces by? Neil, go ahead.
5/14.
Yeah, so we divide everything through by 2, and we get 5/14. And I think Hosanna pointed it out yesterday, I think it was you, that you could reduce it first, right?
Yeah, no, that was me.
Or was it you, Lana? I'm sorry, I knew it was somebody back here. Yeah, you could have canceled out, reduced the 2 and the 4 to being a 1 and a 2 at the start, and that would have gotten us right to 5/14. That, of course, works just as well. Okay, so then finally we get to this. This is always the one that takes a little bit more time, so if you have questions, definitely ask. I'll go as slow as I can here to help you out. But it's always the adding and subtracting takes a little more effort. What do you have to have in order to add or subtract fractions, Jake?
Common denominator.
That's right. And if you look at the denominators right now, it's 5, 3, and 15. Those are not the same, obviously. And so we need to think, using what's called a least common multiple, what would be the lowest common denominator, or at least a common denominator. What do you think, Victoria? 15, right? Because 15 is the smallest number that 5, 3, and 15 all go into. So in order to make this work, what I'm going to do is rewrite. I'm going to write 1/5 minus 2/3 plus 10/15. And because that common denominator is 15, as she pointed out, we really don't have to do anything with that last fraction, right? But the first two fractions we need to do a little bit of work with. So for this very first one, 1/5, what do I need to multiply that denominator by to get to 15? 3. So I'm going to go ahead and put times 3, but I can't just go do that unless I also do something to the numerator, right? I got to do the same thing. So if I multiply the bottom by 3, I've got to multiply the top by 3. That gives me 3/15 minus, and then the 2/3. I need to multiply the top and the bottom by what for that one? 5, right? 3 times 5 is 15. So times 5 and times 5, that would give me 10/15, and then plus 10/15. Now if I look at my denominators, all of them are exactly the same, and so now I can go ahead and combine these fractions. When I add fractions, what do I do with the denominators? keep them exactly the same, right? So I'm going to go ahead and just put equals, and I'll put over 15. I know that that 15 is going to be my denominator, but then with my numerators, I actually have to do the addition and the subtraction. So we're jumping a little bit ahead of ourselves here, but let's see what we can do. What is 3 minus 10?
-7.
-7 plus 10 is 3. Yeah, so we have 3/15, and 3/15 actually reduces, doesn't it?
1.
Down to 1/5. So our final answer here, as we evaluate this, would be 1/5, 1 over 5. Okay, so I know fractions can be kind of scary, and that's probably one of the tougher things to deal with, the addition and subtraction. You seem like you're doing okay, so that's great. We're going to head to the board and practice now, so if we could get one group of folks up at the boards. And by the way, I know that we have, with -3.4, first of all, I'm going to say that that is a real number. In fact, all of them are going to be real numbers. So -3.4 is a real number. I can also see that it is a terminating decimal, right? The decimal just stops. And so that means that it is also rational. This is a real number. It is a rational number. And then the next level down would be integers. And I know that this is not an integer because it has a decimal in it. And so I would stop right there and say it is real and it is rational. And that's it. Okay, so that's kind of what I'm looking for on these. You're going to kind of want to see how much you learn from the video. And this is kind of a good test for you. If you get to the board and you look at that 2/5 that's coming up for number 2 and you're just like, I got nothing. I don't know what to do with that. You probably should go back and rewatch the video, right? And probably take some good notes and relearn what it is you need to relearn. You need to come to class prepared with that material. We can practice and do questions and make sure that you're really, really solid on it. So let's give it a try. Let's get a group up there to the board, looking at 2/5 right there. And let's write down the sets of real numbers that it belongs to. I will write down your options over here. Those are all your options. That's right from the video. Use your notes if you want.
-4 could be a whole number, right?
I'll let you decide.
Yes, because it's not decimal.
Be real because they're all real, and it is rational. The reason why it's rational is because it can be written as a fraction, because there it is, it's a fraction, and that's where we stop, because integers do not include fractions or decimals. Integers, just the kind of the negative whole numbers, if you will, 0, and the positive whole numbers. Okay. Again, if you hear me talking about this and you're just like, I don't know, you should go back and watch the video. All right, let's take a look at number 3. Number 3 is a little tricky. I will forewarn you, just a touch tricky.
I think I know it.
That's not the issue. Now, the next thing that I've seen as I've looked around, I've saw a couple folks that put irrational. Let's remind ourselves of what rational and irrational mean. Rational means that it can be written as a fraction. Irrational means that it cannot be written as a fraction. And that was written as a fraction, right? So that automatically makes it rational. And then if you keep on going down through the list there, 19 is part of the set of integers that I listed on the video, so it is an integer. And it is part of the whole numbers, because the whole numbers go 0, 1, 2, 3, ... And not only is it a whole number, it's a natural number, because the natural numbers go 1, 2, 3, ... So it's basically the entire left side of our little diagram. It's all of them. It goes all the way down to being a natural number. And we were talking about this over here. If a number is a whole number, doesn't that mean that it's also an integer? And if a number is an integer, doesn't that mean that it has to be rational? And then if it's rational, it has to be real. And so it includes that whole left side. Okay, let's take a look at number 4, square root of 7. If you watch the video, this one should be fairly straightforward. Or if you learned from the video, I should say. So check it out. Okay, and then our last one, there's two more. The next one is negative 4. The next one is negative 4. Let's take a look at that one. Okay, so obviously we're looking at a real number. Let's keep going though. All right. All the ones I see over there are good. Nice job. A little too far. Help me. Connor, a little too far. Yeah, too far. It's good. She's working. Close. You kind of skipped a step. So Ashlyn, if a number is a whole number, doesn't it also have to be an integer? So let's think that through again. I feel like you kind of skipped a level there. That's good. No, not quite. You went too far with it. Same thing, Carissa. And so Ashlyn, actually the one that doesn't belong is whole. It's not a whole number because whole numbers are 0, 1, 2, 3, ... The whole numbers do not include any negatives. And obviously that's a negative number. So we'd go real, and then it is rational, I agree. And then the last one would be integer. Okay, so we got it? Got it? Okay, so you just had like an extra. You had an extra in there too. Okay, you had one extra, I think. Okay, last one here, number 6. Negative 0. And then you know the little bar means 6 repeating, right? 0.6 repeating. All right, give it a shot. So that is real and rational. Okay, so you guys have any questions?